Pre-damped vibration related problem. Mass of the vibrating system 2.5 kg. Spring constant 3 Newton per mm. So you have to convert that Newton per mm into meter. You will get 3000 Newton per meter because 3 Newton per mm. 1 mm equal to 0.001 meter. I mean 10 power minus 3 meter. So which is equivalent to 3000 Newton per meter. Then the amplitude decreases to 0.25 value of initial value after 5 consecutive cycles, which means you have to write it as x6 equal to 0.25 x1. I will tell you later why we are writing x6 instead of x5. Then we need to find damping coefficient, which means C. So there is a difference between damping coefficient and damping factor. Factor means eta, coefficient means constant C. So we need to find C value. M value known, K value known. So from that we can find natural frequency. Omega n equal to square root of K by M. K 3000, M 2.5. You will get 34.64 radian per second. There is a reason why we should convert mm into meter because the unit for natural frequency radian per second. So whenever there is a second in unit, then the equivalent value is meter, not mm. So whenever you put k value, you have to substitute in Newton per meter. K means damping coefficient. Then amplitude. So this is free damped vibration, which means the vibration will decrease over a period of time. Here, there are 5 consecutive cycles 1, 2, 3, 4, 5. Here, the ratio of consecutive cycle x1 by x2, x2 by x3, x3 by x4, x4 by x5, x5 by x6 constant. So, 5 consecutive cycle 1, 2, 3, 4, and 5. So 5 consecutive cycle means x1 by x2, x2 by x3, x3 by x4, x4 by x5, x5 by x6. So it will come up to x6. That's why we put x6 here. So these are all equal. From that, I can make a relation. That relation is just multiply all the term. X1 by x2 multiplied by x2, x3, x3, x4, x4, x5, x5, x6. I can cancel these terms. So you will get x1 by x6. So that will come one side. This is equal to, here all the values are equal, which means I can take this value, this and this value as x1 by x2. So I can write it as x1 by x2 power 5. From that, x1 by x2 equal to x1 by x2 power 1 by 5. So move this 5 to another side. You will get x1 by x2 equal to x1 by x6 over 1 by 5. Here, x1 by x2 means ratio of two consecutive cycle. x6 equal to 0.25 x1. This is given. So I can substitute this here. So I can replace it here. So I can cancel x1 on both sides. So 1 divided by 0.25 over 1 by 5, 1.32. So x1 by x2 equal to 1.32. So there is a formula, logarithmic decrement. Del equal to ln x1 by x2, ratio of consecutive cycle. So ln 1.32. So here we have natural logarithm 1.3, that is equal to, that is a formula for logarithmic decrement, 2 pi eta divided by square root of 1 minus eta square. So this is a formula. From that I can find eta value. Eta means damping factor. So take ln 1.32 value, then apply square root squared on both sides. So what will happen? The square and square root will cancel. Here you have to take power 2. So you will get this equation. When you reduce this equation, you will get this form 0.077 minus 39.547 eta squared equal to 0. From that eta equal to 0.0435. So now we got eta value. From eta, I can find C value because eta equal to C by Cc, damping coefficient divided by critical damping. So C divided by 2m omega n. M known value, omega n known value, eta known value. So C equal to eta 2m omega n. 2 into m 2.5, omega n 34.64, then eta value 0.0435. So finally you will get damping coefficient C equal to 7.53 Newton meter per second. So this unit is very important. Newton divided by meter per second. So this is a unit for damping coefficient. So this is how you can find damping coefficient for a given free damped vibration problem.